The paired sample t-test can be applied in many circumstances. So, and paired samples or associated samples or repeated measures t-test, they are the same. So, the design that we have in mind when we talk about repeated measures is a design in which we've got one independent variable and one dependent variable. In the independent variable, that variable is categorical or nominal, and it has two values. And the dependent variable has to be a numerical variable. Okay, so that's the general case. Now I'm going to go through several instances in which this repeated measures design can be used. So one instance is in which the independent variable is categorical or nominal. That is always the case with two values. And here the participants will be paired participants. So one group of participants will be exposed to one value of the independent variable, and another group of participants will be exposed to the other value of the independent variable, but these two groups will be matched participants. So for each participant in the first group, there will be another participant in the other group that is matched. And how is it matched? It is matched with same characteristics. So perhaps a previous test on some ability determines that these two participants are similar, so these are the matched participants. It could be age, so perhaps you've got two groups and you match them with the range of ages, and we match them, people with the same age go together. So an example of this is the study of Winch that we explained in previous master classes, in which the participants were measured in their memory ability before running the study, and then they were separated into two different groups based on their memory capacity, on memory skills, and participants were matched. So participants that had the same memory skill were considered part of a pair. Okay, so this is a case in which we can use the dependent samples or paired samples or repeated measures t-test. The dependent variable is always a numeric variable. So another example of that, let's say that we are measuring the effect of memory load on reasoning skills. And we've got a group of participants that doesn't in the reasoning task that they have to perform, it doesn't have any memory load. And another group of participants that, yes, has memory load. Now, the two groups of participants, they are not two groups that are not related, like in the independent samples t-test. In this case, these groups are matched. So the participants in this group are matched based on some previous measurement or some other characteristic. So because they are matched, then we can do a paired samples t-test or a repeated measures t-test. In this case, the dependent variable will be reasoning skills, and it will be measured as percentage of correct answers. Another instance in which we use this t-test is in which we have as independent variable we've got two values of that independent variable, and one would be experimental condition and the other value control condition. So these are the two types of conditions. Difference with the independent samples design. The difference is that in this case we've got the same participants go through the experimental condition and through the control condition. Which one do they do first? Well, I will go through that later on in this masterclass. But it may be the case that they do experimental first and control second, or control first and experimental second. Depends on the circumstances and the design. I will explain this later. So as an example, participants are, so we are investigating the effect of destruction in the accuracy in performing a task. And the independent variable is destruction and has two values, destructing stimuli and no destruction at all. And then the variable, the dependent variable is accuracy and is measured as the number of correct answers. What happens in here? We've got a group of participants that goes through both conditions. So they have destructing stimuli, let's say first, and no destruction second, or it could be the other way around. I will explain that later. But here is we've got the same group of participants being exposed to the two values of the independent variable. Unlike the independent samples t-test or design, in which the participants are different. So a group of participants go to the destructing stimuli condition and the other group to the non-destruction. Another instance in which this design can be used is we've got independent variable, a pre-intervention and post-intervention are the two possible values, and we've got some numerical dependent variable. As an example, we've got we want to see whether a psychotherapy improves depression or decreases the depression. And so we've got one group of participants that we measure their depression before intervention or pre-intervention, and the same group of participants after they go through their intervention, their psychotherapy, they're measured again in depression. So we are going to compare the same participants before the intervention and after the intervention. Another instance is in which the independent variable is two different conditions. None of them is control and experimental. They're both equally important. And we've got a dependent variable, a numerical variable. So let's say that we are studying how the speed of presentation of stimuli affects the response time in a task in which the participants have to detect whether a stimulus was appeared or not. So when it appears, they have to respond, and the response time, or the time between the appearance of the stimulus and the response, is measured in milliseconds. So in the independent variable, we've got two conditions: fast presentation of the stimuli and slow presentation of the stimuli is the other condition. And the same group of participants is exposed to both conditions. So we are going to obtain measures in milliseconds in the fast condition and in slow condition in each participant.